Hello and welcome to my presentation for the module Sustainable Water Treatment. My name is Theo Engel and I'll be presenting the topic Freshwater Shortage in Ethiopia. Is desalination of seawater a solution? This is a course on sustainability. I'd like to point out the relationship between water and the Sustainable Development Goals. And the first and most obvious relationship is the goal number 6, namely clean water and sanitation. And sanitation also relates to the goal number 3, namely good health and well-being. But water is also used for irrigation. This is used to grow food. So the relationship to zero hunger is given as well. And those are the main goals water relates to. However, as these goals interrelate quite a bit, we will see that climate action, so climate change also has a huge effect on water accessibility. And the goal number 7, namely affordable and clean energy, also has a relationship to clean water. But we'll come to that when we talk about the desalination part. Let's have a look at the freshwater sources in Ethiopia. Ethiopia is located in the Horn of Africa and is home to 12 river basins and 22 lakes. The most prominent probably being the Blue Nile, which originates here and then flows this path northwards, supplying the main Nile River. Also, there's about 25 to 40 billion cubic meters of groundwater potentially available, and Ethiopia receives about 980 billion cubic meters of annual rainfall. This all contributes to the fact that Ethiopia is known as the water tower of Africa because all this water accumulates in the highlands and is then transported downstream into the other countries in East Africa. If we have a look at the population of Ethiopia, we can see it's at about 130 million people, and this then relates to a need for water of about 1 billion cubic meters if we use very conservative standards, and about 5 billion cubic meters of water if we use Western standards, so to say. So if we compare the water availability between Ethiopia and Germany, we can see that the difference is not all that big. And from the previous slide, we could see that theoretically Ethiopia has enough fresh water to supply their whole population. However, the access to fresh water is not a given in Ethiopia. If we have a look at the right-hand graph right here, we can see the percentage of the population that has access to improved access, which means there's no outside contamination in the water, and safely managed access, which is an even higher standard. And we can see that for Germany, both values are above 99%. And for Ethiopia, the improved access is at just below 75% of the population, and the safely managed access is even below 20%. So there's a large gap between availability and access, and this is because missing infrastructure, the weather situation in Ethiopia, and also pollution of the water. And in rural regions, the availability is much worse or much lower. Let's look a bit deeper into the accessibility of water and how this relates to sanitation and health. So a study in 2023 found out that about 75% of the population had access to improved drinking water sources. However, below 30% had access to improved sanitation, and below 1% had improved water on premise. This is obviously a huge concern since safe water, sanitation and hygiene prevents waterborne diseases like diarrhea, cholera and typhoid fever, and many households lack access of the water. And since so few households have access to water at their home, they often have to travel above 30 minutes between their home and a water source. Here's a picture of Ethiopians carrying their water from their water source, which might be a well or a river, to their home. And this is obviously a huge problem for Ethiopia. And it seems to be getting worse since Ethiopia faces a lot of challenges, namely the growing population, climate change, which is responsible for droughts and the unpredictability of the rainy season, as well as geopolitical issues with rivers that cross borders. One possible solution to the problem might be seawater desalination. And the goal of this is quite simple. It is to remove salts from seawater to produce drinkable fresh water. And well, I'll present to you today the two most common methods, starting with the multi-stage flash desalination. And the name comes from the different stages this process undergoes. However, the first one is the seawater coming in, which is then heated up, and distillation takes place. And this happens in all three stages until finally the brine can be removed and fresh water can be collected. In between those stages, of course, the freshwater vapor is interacting with the fresh seawater in a heat exchange process to lose the least amount of energy in this process. Now let's get to the other desalination process, namely reverse osmosis, which is the most commonly used desalination process globally. This, of course, relies on the concept of osmosis. If we have a high concentrated solution and a low concentrated solution, and they're separated by a membrane that only lets through water molecules, we can see the effect that the water migrates to the higher concentrated solution, and the difference is known as the osmotic pressure. How can we make use of that in terms of desalination? Well, if we simply apply pressure on the highly concentrated solution side, we can force the water to migrate to the low concentrated solution side. How would this look like in a potentially reverse osmosis setup? We can see that saline feedwater undergoes pretreatment and is then goes into a pressure pump, which forces water molecules through this membrane, and then finally fresh water can be collected after post-treatment. And what's left is known as the brine, and this is then extracted. So, is desalination actually a viable solution to solve the freshwater issues in Ethiopia? Well, there are major concerns, and the most obvious probably being that Ethiopia is landlocked, so they don't have access to seawater directly. And there is some salty groundwater, and there are some salt lakes in the northern region, like this salt lake right here. However, it's still to be viewed critical if desalination is an actual solution to supply fresh water right there. The landlocked state just poses the problem that political cooperation is required between Ethiopia and Somalia or Eritrea, and the transport is also pretty expensive in terms of energy. So about 1,600 kilometers of transport equals the desalination cost in terms of energy. So you'd rather build those plants where the water is actually needed, so you don't have to use so much energy for transport. And speaking of energy, well, the energy cost is about 3 to 4 kilowatt hours per cubic meters for the reverse osmosis. And if we think about where the energy is coming from, well, Ethiopia plans to expand their hydropower facilities, so they would be generating energy where fresh water already is, and then sending the energy to a place where seawater is, to then send the fresh water back to Ethiopia, and this just seems not quite viable. And then there's also the universal issue of brine management for all desalination plants. Yeah, what are some options that might be an alternative to desalination? Well, one option is the integrated water resource management approach. And the paper I cite right here claims that water scarcity as a result of poor management, poor infrastructure, and climate stress. So they came up with this more sustainable and locally based approach. And the first step in this approach is rainwater harvesting, which is just the collection of rainwater, plain and simple. And this can be done on rooftops or so-called rock catchment areas. And yeah, for the rooftops, this then can be stored at a household level. Yeah, here are the illustrations to the respective constructions, and they're quite simple. So we have this catchment area for the rock catchment. We then have a water filter and closed storage tanks. Yeah, for the rooftop collection, we have the scatter system where water is collected in those tanks down here and can be pumped up to the top of the house again to be used for, well, flushing toilets, other sanitation purposes like washing clothes, washing dishes, etc. And then they also propose the building of sand dams in some areas just to reduce or to capture runoff and reduce evaporation. Yeah, the next thing is water recycling and reuse. So instead of just treating wastewater as wastewater, they suggest reusing it for agriculture. And they also suggest recycling to reduce the reliance on scarce fresh water. They also came up with some low-cost treatment methods, and yeah, they suggest some biofilters like those seeds mentioned here, and there are also some bamboo-derived filters for water. Yeah, speaking of filtration, also riverbank filtration could be employed more, and yeah, solar desalination for saline groundwater in the northeast. And here desalination comes up again, however, not in a holistic point of view as a solution for the whole country, but rather as a very specific solution for remote locations. And the last thing is the improvement of the infrastructure. So especially the treatment facilities should be expanded to treat more wastewater, and leaky networks should be repaired, and distribution efficiency should improve. What are the goals? Well, in the short term, community engagement and conservation campaigns. In the medium term, improved infrastructure and allocation planning. And in the long term, the adoption of rainwater harvesting systems, as well as sand dams and water recycling in general. Let's come to a conclusion. While Ethiopia has vast water resources, safe drinking water access remains quite a challenge. And this is mainly due to missing infrastructure and pollution of drinking water, and also some governance gaps. We discussed the desalination, and it is an important technology globally. However, for Ethiopia, it is probably not viable at scale, because of the landlocked geography, as well as the high energy and transportation costs. What might be a more suitable option? Well, there's a more sustainable approach that includes rainwater harvesting and the reduction of wastewater and water recycling, as well as decentralized low-cost treatments of water. And all in all, you can say that Ethiopia's water problem is not one of scarcity, but rather of management and equitable access. So since this is a video, you unfortunately cannot ask any questions, but I would like to thank you for watching nonetheless.